Okay, so in the first video for lesson 1.6, we just looked at some basic equations to solve. With this one, we're going to look at some more complicated ones, most of which dealing with fractions. Now, I don't know how you guys feel about fractions, but I used to always hate dealing with fractions. So whenever I try to solve an equation, and if there's fractions involved, I look to see if there's a way for me to get rid of them. Now, some of you guys might think you already know how to do this by, well, just change the fractions to a decimal. You don't want to do that. The problem with doing that is, look at this first one where we have 2/3. 2/3 as a decimal does not terminate, meaning it doesn't end. It keeps going on and on and on forever. It's 0.6666 repeating. So if I were to write this out, I'd have to write it as 0.67, which when I go and do all the work, it's going to end up with an answer that's not accurate. It's going to be a little bit off. So we don't want to round. So if we don't want to round and we want to get rid of the fractions, what can we do? Well, here's what you want to make sure you do. Anytime you see fractions, to get rid of them, do this step. We're going to multiply every term by a common denominator. Really, I guess the phrase would be a common multiple of the denominator, but I think you'll get the idea better if we just leave it like this. Here's what I mean. We're trying to find a number that both 3 and 2 will divide into evenly. Like 12. 3 goes into 12, 2 goes into 12. So we could have used 12 if we want. But the smallest one is going to be 6. Now you might say, well, where did you come up with 6 from? Or how would I even know to get 6? Because I wouldn't know how to do that. If that's the case, if you don't know where I came up with 6, or if you have a hard time finding a number that works, what you do is you look at the numbers in your denominator. We don't care about the numbers in our numerator. We look at the numbers in our denominator and we say, well, let's multiply them together. 3 times 2 gives me 6, so that's the number I'm going to use. That always works. It doesn't always give you the smallest one, but it will always give you a number that works. Now, what you're going to do is you're going to multiply every term. Now, each of these pieces, the 2/3 x, that's a term. 1/2, that's a term. 5, we'll call that a term. Each of those are terms. So multiply the 6 times each one of those. So 6 times 2/3. Now, some of you you might be pulling out your calculator or going to that right now. But the problem is, on your test, you may not be able to use a calculator. So how can we take 6 times 2/3 without using our calculator? Notice my arrows. Notice my arrow is taking 6 times a 2. That's where it's pointing at least. That's an easy way to remember how to do this without using your calculator. 6 times 2 is 12, and then we divide by 3. 12 divided by 3 gives me 4, so I have 4x. 6 times 1 is 6, divided by 2 is 3. Now granted, half of 6 would be easy to think of, because that would be 3. But lastly, 6 times 5 is 30. Now I can solve this problem easily, because we have no fractions in here. I can just subtract 3 from both sides, giving me 4x equals 27. And now I'm going to divide both sides by 4. And when I do that, I'm going to get x equals 6.75 as my answer. Again, in your assignment, you'll be asked to check it. To check it, if you want, you can just use your calculator and just take 2/3 times 6.75 plus 1/2. When you do that, you'll get 5 as your answer, and so you can tell that it checks, that it works out. But for space, I'll just erase that. And let's look at this next one. With this next one, it looks a little different. I have y divided by 4 plus y divided by 6. Remember what I said earlier. We're trying to find a common denominator. So we're trying to find a number that goes into both, we're trying to find a number that both of these numbers divide into. So we would not say 2, because you might say, well, 2 goes into 4 and 2 goes into 6. That's not what we're looking for. We're looking for a number that both the 4 and 6 divide into. So one trick that you could use is multiply those together. When you do that, you get 24. There is a smaller number we can use. Can you think of it? If you thought of 12, you could have used 12. because 4 goes into 12 evenly and 6 goes into 12 evenly. But I'm going to show you that using this trick of multiplying 4 times 6 will also get you the same answer. So what we're going to do is we're going to take 24 times y. 24 times y is 24y. Divided by 4 gives me 6, but it's 6y. 24 times y is 24y again. Divided by 6 gives me 4y. 24 times 5. If you had to do that without a calculator, here's a way to do it. Start out with the 20. 20 times 5 is 100. Go to the 4. 4 times 5 is 20. Together that makes 120. And now you can see what I want to do is I want to add like terms. So I'm going to take 6y plus 4y, which is 10y, equals 120. Divide both sides by 10, and you can see that your answer for y would be 12. And again, you can check your work by putting that in here. 12 divided by 4 is 3. 12 divided by 6 is 2. 3 plus 2, sure enough, gives me 5. What if the fractions are on opposite sides of the equal sign? Well, it still works out to be the same. We want to take and look to see, find a common denominator here. I can use 10. 5 times 2 is 10. But remember, we multiply every single term by that 10. So not just the fractions, everything on both sides of the equal sign by 10. So 10 times 3 is 30, divided by 5 gives me 6. This is 6x. 10 times 1 is 10. And this is going to be the common mistake. The most common mistake is that people forget to multiply everything by this number. Sometimes people just multiply it by one side of the equal sign, sometimes just the fractions. Make sure it's every single term you multiply by whatever the common denominator is. Okay, so now let's look at solving this. This is just like what we did in the previous lesson's assignment. We have a variable on both sides, so I'm going to subtract 5x from both sides. 6x take away 5x, leaves me just 1x. Subtract 10 from both sides. Leaves me with x equals 20. Okay, enough about fractions. Let's look at some more with the distributive property. Yesterday, on the previous lesson, we distributed numbers that were directly outside of the parentheses. It doesn't always have to be a number. Sometimes it's a negative. In this case, you multiply everything in parentheses by that negative, not the 2x. The 2x stays the same. So negative times 4x makes that a negative 4x. Negative times a negative 2 makes that a positive 2. And we're done with the distributing. Now, some of you guys had previous math teachers, maybe in middle school, that taught you to change a minus to be plus a negative. Please don't do that. That's where I see a lot of mistakes, is when people make those changes and then they make their plus and make their negative so small they can't see it. And so just leave it as a minus 4x. Okay, so 2x minus 4x makes that a negative 2x. Now I subtract 2 from both sides. Gives me negative 2x equals 10. Divide both sides by negative 2. When you do that, you get negative 5 as your answer. And again, to check your work, we would just take 2 times negative 5 minus 4 times negative 5 minus 2. I want to see, does that equal 12? Order of operations tells us to take 4 times negative 5, which is negative 20. Negative 20 minus 2 would be negative 22. And 2 times negative 5, that's negative 10. Well, this becomes negative 10 plus 22, which gives us a positive 12. And that does equal the 12 that we have on the right, so that's how you can check it. Okay, let's look at this last problem. A lot of people make this mistake of saying, oh, 5 minus 5, that's 0, that's gone. That's also wrong. Remember, anytime we see the parentheses, the first thing we do is distribute. Now, what you want to notice is that when we distribute this 5, it's a negative 5. So this 5 out here stays the same, the first one. But negative 5 times 2x would make that negative 10x. Negative 5 times negative 2 would make that a positive 10 equals 45. And now I see that we have like terms here. The 5 plus 10. We want to cover up that negative 10x. I'd ignore that for right now because 5 plus 10 would be 15. So I'd have 15 minus 10x equals 45. I want to get the x by itself, so I subtract 15 from both sides. Leaving me with negative 10x. Don't forget to bring down the minus with the 10. So it's a negative 10x equals 30. Last step, divide by negative 10. X would equal a negative 3. Sometimes people have a hard time checking this. So let's just see real quickly how we would do that. I want to see, does this equal 45? Order of operations tells us to simplify inside of parentheses first. 2 times negative 3 is negative 6. Negative 6 minus 2. They're both negative, so you add them together and it stays negative. Negative 6 minus 2 would be negative 8. Now remember, this is a negative 5 times a negative 8. So when I add those, or when I multiply those together, negative 5 times a negative 8 makes a positive 40. So we get 45 equals 45. So it checks. So hopefully you have a better understanding now of how to do this, and good luck with your assignment.